Last winter, I was having a walk and having some mathematical discussion with one of my friends who was in class 8. And from the other side, a question came up that why there's no simple divisibility rule of 7. Like all small numbers have a very nice simple divisibility rule, but 7 seems to have none. And it has a divisibility rule, but it is very complex. Hearing this question, I related that at a point of time when I was in class 7, 8, 9, 10, I also had such a question. Why 7 has no such simple divisibility rule as other numbers have. But since I had done my graduation in mathematics and in this time I was a bit familiar with, like I had in the back of my mind an idea that why and how divisibility rule might have been formed, a bit vague idea. And I told that person while discussing that, see, the divisibility rule of 7 depends upon, or any number, depends on what remainder that numbers give when 10 is divided by that number, or when 100 is divided by that number, or when 1000 is divided by that number. The person did not understand well about it. I tried to explain in a little more, like giving examples, but that person did not understand at that point of time. Now, while telling this, I don't expect that you get what I am telling you, but now what I will do, that I will tell you the rule which I made, okay, and then we will derive it all. And the interesting part is that I did not find just one divisibility rule of 7, rather I found many. And not only of 7, but I found a general divisibility rule from which you can find many divisibility rule of any number if it so exists. Okay, so let's first see the divisibility rule of 7 which I found out, so that you can just feel that how it came up, and then we will go into the derivation and the general divisibility rule which I found out. So here there's a random number which I have written, and now we are going to find whether this number is divisible by 7. So see, we are going to use some multipliers, and now I'm going to write some multipliers. For each digit, there's a multiplier. So 1, 3, 2, minus 1, minus 3, minus 2, 1, 3, 2, then minus 1, minus 3, minus 2, if there were more digits. So we just need to remember this, that the multipliers we are going to use is 1, 3, 2, minus 1, minus 3, minus 2, and so on. So now we are going to see whether this number is divisible by 7. So we are going to multiply this. 2 into 1 is what? 2. Now 3 into 1, we are going to add all of them. 3 ones are 3, plus 2 ones are 2, then minus 5, then minus 9. If we multiply this, then minus 14, plus 1, plus 3 to the 6, plus 3 to the 6. Now 2 plus 3 plus 2 is like 5, 6, 7. 7 minus 5 will be equal to 2. And 2 minus 9 will be equal to minus 7. Minus 7 minus 14 minus 21 minus 21. And then we have here plus 6 plus 7 plus 6. So plus 7 plus 6, which will be equal to minus 14 plus 6, which will be equal to minus 14 plus 6. And that is nothing but, if we give, that is minus 8. Now, since minus 8 doesn't come in the table of 7, we are going to deal with, like, minus 7 comes in the table of 7, minus 14 comes in the table of 7. So we are going to deal with the integers in this case. So minus 8 doesn't come in the table of 7. So this number is not divisible by 7. And interestingly, the remainder which this number will give when divisible by 7 will be congruent to this, like will be same as the remainder which minus 8 will give. And if you're not familiar with this, I'll just add 14 into this, so the remainder won't change because you're adding a multiple of 7. So 14 and minus 8 will be what? It will be 6. So if you divide this number by 7, you will get a remainder 6. Actually, you understood what the divisibility rule is. You just need to, if I do it for a smaller number, like supposingly 3, 1, 6, 7. Okay, now 1, 3, 2, minus 1. And we have to check whether this number is divisible by 7 or not. So 7 comes at 7, 7 plus 18 plus 2 and minus 3. So it will be 18 plus 2, 20, 27, 27 minus 3. 27 minus 3 is what? 27 minus 3 is 24. Since 24 is not divisible by 7, so this number is also not divisible by 7. So this is what the rule is. This is one of the rules. Now let me tell you another rule by which we can do the divisibility of 7. So here I have written yet another random number, and now we are going to check whether this number is divisible by 7 or not from another rule. Now do this kind of thing. Okay, and we are going to use multipliers in this case also, but we are doing some pairing. 2, then 1, then 2, then 1, then 2, then 1. And now we are going to multiply. The multipliers which we are going to use is 1, 2, minus 1, minus 2, 1, 2, minus 1, minus 2. It will go on so on. Okay. Now the remainder, we will multiply 91 with 1, 4 with 2, 13 with minus 1, and we'll add them all up. And if that number is divisible by 7, then this number will also be divisible by 7. One more thing, we can also do this, that we can find the remainder. Like one way was that, and that applies to the previous question also, like the previous method also, which we were doing. So first let me do it in a simple way. I will multiply 91 with 1, so it will be 91, plus 4 2s are 8, and 13 into minus 1 is minus 13, then minus 4, then 57 plus 57. We multiply 57 and 1, and then 4 into 2 is 8. Now you add them all up as you add integers, and if this number is divisible by 7, like the number which you get after doing all this calculation, if that is divisible by 7, then this number will also be divisible by 7. But I am not going to do all that. I will make my calculation more simple. What I am going to do now is that I won't be multiplying 91 with 1. Rather, I will multiply 91, since I am checking the remainder for 7. So I will think this 7 comes, I will see what remainder this number 91 gives with 7. So I will know that 13 7s are 91. So this 91 will give me what remainder? 0. 4 will give me what remainder? 4 will give, when divided by 7, 4 will give me which remainder? Then it will give me 4. 13 will give me what remainder? So it will give me 6. Or I can also write here that it will give me minus 1, because when divided by 7, 13 can give the remainder 6, which is also minus 1 if you are familiar with the integer sort of divisibility. Okay. Now what 2 will give? 2. 57 will give me what remainder? It will give me 1. What remainder 4 will give me when I divide it by 7? Then it will give me 4. And now I'm not going to multiply 91 with 1. Rather, I'll be multiplying 0 with 1. Okay, like these numbers are just, you know what I have written over here. So I'm going to multiply 0 with 1. So 0 1s are 0, plus 4 2s are 8, plus 6 into minus 1 is minus 6. So I have to write here minus 6. Then 2 into minus 2 is minus 4, plus 1, plus 8. Now if this number is divisible by 7, then this entire 4, 5, 7, 2, 1, 3, 4, 9, 1 will be divisible. So let's calculate this. So 8, 8, 16. Okay, 8, 8, 16, 16, 17, and 17 minus 10. 17 minus 10 is what? 17 minus 10 is 7. So this number will be divisible by 7. And if you calculate this entire thing, then also you will get such a number which will be divisible by 7. But the more easier way was this one. Okay, and one more thing. If we are going to do the same thing, like I'm going to write the same number, 4, 5, 7, 2, 1, 3, 4, 9, 1. Okay, and we are going to use that multiplier, the previous method. So I'm going to use the multipliers 1, 3, 2, minus 1. Okay, let me write a bit big, okay, because it won't be quite visible to you. 4, then 3, 4, 9, 1. Now I have to use the multiplier 1, 3, 2, minus 1, minus 3, minus 2, 1, 3, 2. I'll use that way. But before doing that, what I will do, that I know 91 is coming in the table of 7. Okay, this is yet another sort of thing which I can do. 91 comes in the table of 7. So instead of 91, I'm going to write 0, 0, because it gives no remainder when divisible by, when I divide it by 7, 91 will give the remainder 0. So instead of 91, I'm going to write 0. Okay, if I divide 21, then also it is going to give me remainder 0. So instead of 21, I can write 0. 7 will also give me remainder 0. So I'm going to write 0 instead of this. And 34, what remainder will 34 give me? So 28 comes in the table. So 28 comes in the table. So I will get the remainder 6. Okay, so I can write, instead of 34, I can write 06. 2-digit number, I will replace with 2-digit number. The remainder it gives is 6. So I'll replace it with 06. 45. 45 gives me the remainder 0, 3. So I'll replace 45 with 0, 3. And now I can use the multipliers. Like I can do it very quickly. I was explaining to you, but I can do it very quickly and anybody can do it. Now what we are going to do, we are going to multiply that same thing, 1, 3, 2, minus 1, minus 3, minus 2, as we used to do in the previous one. Or you can use this also. With these numbers, you can use the same. You can pair it up 1, then pair this one and multiply 2. Both methods you can use. Now I'm going to use the previous method. So 1, 3, 2, minus 1, minus 3, minus 2, 1, 3, 2. And now I'm going to, since we are multiplying by 0, these will all cancel while adding. So we will get here 6 2s are 12. Then we are going to get 3 3s are 9. And no other number we are going to get. So 12 plus 9 is what? 12 plus 9 is 21. And 21 is divisible by 7. So this entire number will also be divisible by 7. Okay? So this number is divisible by 7. You can check any other number, and this divisibility rule will surely work because it is dependent upon some basic rule of math, and there's a derivation for it, and I'll show you the derivation now. Okay, now we are going to derive all this, where this rule came from. And you can also make another rules. Like there can be many rules for 7, there can be many rules for 13, and numbers like 17, and all these numbers you can find a rule to divide them. And let's move on to the general divisibility rule derivation. So first of all, I will have some notations for you, and you can see it over here, the same remainder notation. Like if you see the remainder which 7 gives when we divide 1 by 7, then the remainder which we get is 1. If we divide 2 from 7, we get the remainder 2. And so on, like if we divide 3, then we get the remainder 3. We divide 4, then we get the remainder 4. And I will show you just a thing, okay? And you will understand it in a more proper way. Okay, so see here. These are the natural numbers, and this is what the remainder they give when divided by 7. So 1 gives the remainder 1, 2 gives the remainder 2, 3, 4, 5, 6 gives the remainder 3, 4, 5, 6. And then 7, since 7 is divisible by 7, so it gives the remainder 0. And then 8 gives 1, the remainder 1, 9 gives 2, 10 gives 3, and so on. Okay, so the remainder, and it goes on like 1, 2, 3, 4, 5, 6, this pattern of remainders, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 0. This goes on in case of 7 if we see the natural number list and the remainder which it gives. Now the thing is that I am going to have a notation that Rk of A. Okay, the remainder when we divide A from K. Okay, so this is the same remainder notation. Like remainder of 1, if we divide 1 from 7, we get the remainder 1. And if we divide 8 from 7, 1 plus 7, 8, then also we get the remainder 8. Also, if we divide 8 plus 7, that is 15 from 7, then also we get the remainder 1. Okay, in all these cases, we get the remainder 1. So the same remainder notation, like R7 of 15, will be equal to 8. Okay, because 15 gives the same remainder as 8 gives. Okay, R7 of 15 is also equal to 1. Okay, so see what it does. R7 of A, okay, or in general Rk of A means that the remainder which A will give when divided by K is the same as the remainder which B will give when divided by K. If I write Rk of A equal to B, it means that A and B both will give the same remainder when divided by K. Okay, B is not the remainder. See, when 15 is divided by 7, the remainder is actually 1. Okay, but 8 is also same. Since 8 will also give same remainder, so R7 of 15 is equal to 8. Okay. Now the another remainder, like the actual remainder which is actually denoted by this thing. Rn of K, A is equal to M. Okay, the actual remainder when a number A is divided by a number K is equal to M. It is the natural, the least natural number remainder notation, which means that the remainder which A will give when divided by k is m. Okay, so this is in usual sense, the remainder which you know, like remainder of 25 when divided by, say, k is equal to 7a. Then the remainder which 25 will give when divided by 7 is what? You know that 21 will come in the table of 7 and the remainder will be 4. So this is the usual remainder which you know. And this notation stands if 15 and it gives same remainder when divided by 7, then we can write in this way. Okay, that's very simple. Now one more notation is the remainder, the smallest, the least integer remainder. We can also write that the remainder here are, when we divide 25 from 7, the remainder which we get is 4. But the same remainder, this 4, we can also write, if we subtract 4 minus 7, then it will be minus 3. And we are actually talking about the least, the new notation, Ri, k of a is equal to m. Here we are talking about the least integer remainder. Okay, for example, in case of 7, we can, the natural number remainders which we get is 0, 1, 2, 3, 4, 5, 6. But if we make that in integers, then the remainder which we are going to get is rather 0, 1, 2, 3. Instead of 4, we are going to get what? Instead of 4, we will get 4 minus 7, which is minus 3. Then for 5, we will be writing minus 2. And for 6, we will be writing minus 1, because the remainder which minus 1 will give, the same when divided by 7, the same remainder 6 will give. The remainder which minus 2 will give, the same remainder 5 will give. Okay, so this is the least integer remainder notation. Okay, this one, Rik of a. And this means, which means that m is the smallest integer which will give the same remainder as a when divided by k. Okay, now we will come to the remainder of the products and the remainder of the sums. That is another rule for you, so that you can understand what derivation is from the very basics. See, another thing which I noted at that time was that the remainder which supposedly 50 will give when divided by 7 will be same as the remainder which I can write 50 as 5 into 10, and the remainder which 50 will give will be same as the remainder which 5 will get into the remainder which 10 will get. Okay, this I observed it was a common observation, like if you try to just plug in some values like 10, 20, 30, 40, 50, 60, 70, 80 and divide it by 7, then you will find that this thing is happening. Okay, there's a sort of pattern. And from that pattern, it might be a well-known thing that the remainder which 7 gives when it is like there's a multiple, like R7 of AB will be equal to R7 of A into R7 of B. It is very simple, but I'm just telling you how can you observe that, like how can you feel it intuitively. So R7, like 5, it will give what remainder? It will give the remainder 5. 5 divided by 7 will get what remainder? 7, it will give 5. And when 10 is divided by 7, it will give what remainder? It will give the remainder 3. So R7 of 50 will be equal to what? Like 50 will give the same remainder as 15 will give when divided by 7. And we know that 50 will give the remainder 1 and 15 will also give the remainder 1. So in this way, what happened that instead of checking whether 15 is divisible by 7 or not, we are checking a smaller number whether 15 is divisible by 7 or not. So actually the number which we have to check becomes a bit smaller if we apply this rule. Other rule is, and this rule goes like this, the remainder of product rule goes like this, that R k of AB, A into B, is equal to R k of A into R k of B. Okay, the remainder which AB will give when divided by K will be same as the product of the remainders which the remainder which A will give when divided by K and the remainder which B will give when divided by K, and we will just multiply it. Okay, and there another rule is Rk of A plus B will be same as Rk of A plus Rk of B. This can be very easily derived. Many of you might know this, but you can just plug in some random values. Like you can put k equal to 7 and or you can put k equal to any number which you like, and you can plug in some values for A and B, and then you can check that whether this works or not. You are familiar with what RK denotes, and you can just check it by your own. So I'm just moving a bit more quickly to the general divisibility rule so that the video doesn't be very long, and I'm giving you some works that you can do by yourself. Okay, so I'm just going to deal with 7 to make you understand how it will be like. So 1 gives, if you see 1 gives the remainder 1 when we divide by 7. And what remainder does we get when we divide 10 by 7? Okay, so 100, we get the remainder 3. If we divide 100 from 7, we get the remainder what? 2. You can do it by yourself, that when we divide 100 in the table of 798 comes, so we will get the remainder 2. In case of 1000, when you divide, you will see that the remainder which comes is actually 6, but we can write that 6 is actually minus 1. So the remainder comes as minus 1, and so on. This is the remainder which these numbers, this 1000 gives when divided by 7. In general, it can be any number, like you might not be dividing by 7, by any other number, and you can get these all numbers. Okay, those numbers which we use as multipliers. So these are those numbers, and we have done it with what? We have done it with 7. You could also have done it with 11. Supposing you did it with 11, you would have got, when you divide 1 from 11, then you get 1 as a remainder. When you divide 10 from 11, you get minus 1. Then 100, then you get 1, minus 1, 1, minus 1, 1, minus 1, and so on. If you do it with 3, then if you divide 1 from 3, the remainder you are going to get is 1. Then with 10, you are going to get 1, 100, 1, 1, 1, 1. So the multiplier we are going to use if we are going to have with 3 is 1, 1, 1, 1, 1. In case of 2, you will find that the remainders, if you divide 1 with 2, you get 1. If you divide 10 with 2, you get 0. If you divide 100 with 2, you get 0, 0, 0. And that's why the divisibility rule of 2 is what? In case of 7, 8, 7, 3, 2, 5. If you need to check whether this number is divisible by 2 or not, so you should use multiplier 1, 0, 0, 0. And you have to just check the last digit, because if you multiply all these, this will be 0. So 5 ones are 5. So you have to actually check whether 5 ones are 5. 5 is divisible by 2 or not. So this is the divisible. For 2, the multipliers will be this. For 3, the multipliers will be this. For 11, the multipliers will be some other numbers. And for 7, these are the multipliers in the case of 7. So I have made a complete list of the multipliers. But the thing is that you have just have these multipliers and you can apply the rule for one digit. Other thing which I noticed was that if I want to check, this will actually give you, if you use these multipliers, then you will actually get the remainder. Not just you will check the divisibility, but you will get the actual remainder which any number will give. Okay, supposedly you are using multiplier 132 in case of 345. Okay, so you are checking the divisibility whether 345 is divisible by 7 or not. So you are using the multipliers 132. So 5 ones are 5. 5 plus 12. 5 plus 12 is 17, and 17 plus 6. 17 plus 6 is what? It is 23. So this number will give the same remainder as what 23 will give, and 23 will give the remainder 2. So when divided by 7, this number will give the remainder 2. But in this case, we are not just checking the divisibility, but we are also checking whether this number will give what? Remainder. If the remainder is 0, the number is divisible. If the remainder is anything else, then the number is not divisible. But you can also use any, like the multiplier which you want to use. Supposing this is the number 3, 4, 5, 6, 3, 2, 1, 9, 7. Okay, so you can use the multipliers, not just 1, 3, 2. You can start it from anywhere. You can start the first digit from 3 and then 2, then minus 1, minus 3, minus 2, then 1, 3, 2, and so on. Okay, in that case, you won't actually get the remainder. Like if I want to check whether this number is divisible by 7. So I can start my multipliers from 2. Okay, I will start from 2. So after 2 comes minus 1. Minus 1, minus 3, minus 2, and so on I will go. Okay, 1, 3, 2, minus 1, minus 3. Okay, I have to do 1, 3, 2, minus 1, minus 3, minus 2 only. But I can start from any point and I can use these all as multipliers. Also, you have the facility to since 56 is divisible by 7, so you can make it zeros, and then you will rather multiply by these numbers, not this 56. Okay, so this was one of the pattern which, like, you can use this kind of thing, and then also you will get the same divisibility thing. Another thing is that in case of the other divisibility rule which I told you was made in this way: 3, 4, 5, 6, 8, 9. And you have to use the multipliers what? 1, 3, 2, minus 1, minus 3, minus 2. Here, what you can do is, rather than multiplying this number with 1 and this number with 3, you can multiply this entire number with 1. Okay, so you can remove this 3 from here, because you are going to multiply all this both number with 1, and you are going to multiply this number with 2. Again, you will remove this multiplier minus 3 from here, and you're going to multiply this entire thing, this both these numbers, this 45, not 4 and 5, rather 45 with minus 1. And so on, you can do such a thing. And from this came that divisibility rule, which I introduced in the second method of dividing by 7. Okay, and such a kind of divisibility rule, a very nice divisibility rule comes up in the case of 7. Of one more divisibility rule which I can tell you, which you can make, is you can for 7 only I'm going to tell. Okay, 3, 4, 5, 6, 8, 9, 2. This is a random number, okay? And rather than using multiplier 1, 3, 2, okay, so I have used the multiplier 1, 3, 2. Supposingly I have written. So here I will be writing 1, but here 3 and 2 I won't write. Okay, I will rather write here minus 1. And then I will skip minus 3, minus 2, and I'll write what? 1. Then I'll skip 3, 2, and since there are no numbers, I am not going to write anything. And you have to make a bar over here. You are going to multiply this entire 3 digit by 1. Then you're going to multiply this 3 digit by minus 1. And you're going to multiply this 2 digit from 1. And then you are going to do that addition process. And the remainder which you get in that case will be the same as the remainder which this number will give. Okay. And you can also, if you just want to check not just the remainder, you don't want the remainder, you just want to check divisibility, you also have the independence, like you can shift this pattern anyway, okay, left, right, you can shift this pattern. In that case, it won't give the remainder, but at least you will find whether the number is divisible by 7 or not, okay, or by any number as such. I also look for did that what it will give in 1 for other numbers, not just 7. I did it for 13, I did it for 17, and all the numbers which I found, I have also made a list of it. But for an instance, I will just show you the general divisibility rule. You can look for your reference if you wish to in detail. I will also be attaching a PDF. And one more thing, that this divisibility rule will not just work for our decimal number system, but also for binary number system with some sort of modification. Instead of the power of 10, we will be using the base which we use. For binary numbers or for any base number which we can use this divisibility rule. And there we go. I made a list. Okay, a list. Let me show you that what patterns come up. When dividing by 1, we get this pattern, 0, 0, 0 pattern, because anything is divisible by 1. In case of 2, we get this pattern, which I showed you, 1, 0, 0, 0. Okay. In case of 4, we come up with a different pattern, which you can see. I will be linking a PDF so that you can see. See, in the case of 6 comes the pattern 1, minus 2, minus 2, minus 2, minus 2. But we usually have a rule that we will do it with 2 and 3. If it is divisible both by 2 and 3, then that number is divisible. And with 7, you can see the rule 1, 3, 2. Okay, 1 is here. 1, 3, 2, minus 1, minus 3, minus 2. These are the multipliers which we get. In case of 8, we get the multipliers 1, 2, 4, 0, 0, 0, 0, 0, 0. So that's why there is a rule that we have to check only, we just take the last 3 digits, and if that number is divisible by 8, then the entire number is divisible by it. In case of 9, we get these multipliers as 1, 1, 1, 1, which is same as 3. And so the divisibility rule of 3 and 1 is actually the same. In case of 10, the multipliers which we get is 1, 0, 0, 0, 0, which is same as that of 2. And that's very easy. That 2, 5, and 10, we will get on same multiplier, I think. It is mentioned in this, I think, the same multiplier will be there. And so the divisibility rule of these 3 numbers are very easy. In case of 11, you get the multipliers 1, minus 1, 1, minus 1. In case of, if you see the natural number multipliers, they are 1, 10, 110, 110. In case of integer, you see the multipliers are 1 minus 1, 1 minus 1. So you are familiar with the divisibility rule of 11. Such a very nice pattern I got in the divisibility rule of 13 also, and also in the case of 37, I suppose. So if you see, this is actually a general divisibility rule where you can find many ways. I have just stated some of the ways of dividing by 7. You can actually find more ways of dividing by 7. And here I end up my video. I think it's quite long. And thank you for watching. You can subscribe to my channel, and I will really appreciate that. Also, you can like and share the video. Thanks for watching.